Hey, welcome back to Show Your Work. So today I just want to do a full breakdown of fractions. Go from the very basics to the real complicated, give you all the rules and all the tricks on how to work with them. So let's get into it. So, starting with the very basics, what is a fraction and how do we talk about it? So a fraction is just written as one number over another number. We usually read it as x over y. You might also see this with a slash like that. We call the number on top the numerator, and we call the number on bottom the denominator. And what literally is a fraction? First thing to know is that what it means, x over y, just means literally x divided by y. So because of this fact, there's a ton of fractions that we can just do that division and we have a much simpler answer for. So for example, anything divided by 1 is just that thing, and anything divided by itself is 1. So this might seem obvious, but this comes up again and again, and it's a very important fact to remember. If you just see a number alone by itself, well, you know that's an implied fraction. There's always a 1 beneath every whole number, because anything divided by 1 is just that number. And remember, anything over itself is equal to 1, no matter what that anything is. Even if it's somewhat complicated, 13 over 13 is 1, but so are things like pi over pi, root 2 over root 2. Anything over itself is equal to 1. And remembering that fractions are just division. So a whole bunch of other fractions we can simplify just by doing that division if it has an answer. So for example, 10 over 5 is just 10 divided by 5, which is 2. 27 over 9 is 3. 8 over 2 is 4. 35 over 7 is 5. So you might be noticing already one thing that's going to help you get better with fractions is to get a little bit better with division. Some of these are obvious and easy to spot. Some of them are less obvious, but still reduce to a whole answer. So the more comfortable you can get with division, at least at some of the smaller number levels, the better you'll get with fractions. All right, moving on. So like I said, fractions are just division. So this means that a whole bunch of fractions just have a whole number answer, and every other fraction has a decimal answer. 1 divided by 2 is 0.5. 1 half is 0.5. 2 halves is 1. 3 halves is 1.5. 4 halves is 2. So if all fractions can be written as decimals, you might ask, why do we want fractions? Well, the answer is they're better often than decimals and they're nicer to work with. Admittedly, sometimes the decimals are really nice. For example, we have 1 half is 0.5. That's pretty nice. 1/5 is 0.2. 1/4, 0.25. So these are pretty nice to work with, and that's not too bad. But not so nice is trying to work with something like a third, which is 0.3 repeating, meaning that threes just go on forever. There's an infinite amount of threes after that. That's very difficult to work with. Even harder is something like 1/7, which is 0.1428557. All of that repeating. So it's 1428557, 1428557. Trying to multiply with this decimal expansion is basically impossible, and much easier to work with is just this fraction, 1 over 7. All right, let's get into how we work with these. Starting with the easiest operations, and that's multiplying and dividing. So how do we multiply and divide? It's very intuitive and almost exactly what you'd expect. Here's the rule. If we have one fraction, x over y, times another, a over b, we just multiply the tops together, the numerators together. So this is x times a over y times b. And we multiply the bottoms together, the denominator. So all multiplying fractions is just doing two individual multiplications. So for example, 1/3 times 1/2. We just multiply the ones together and get 1. Multiply 3 times 2 and get 6. So 1/3 times 1/2 is 1/6. Let's do another one. 2/5 times 3/7. We just multiply the tops together. 2 times 3 is 6. 5 times 7, 35. Now division is only one extra step. I like to think of division as just flip the second fraction and then multiply. So what does that mean? If we have x over y divided by a over b, well, that's the same as x over y times flip b over a. And now we just multiply as normal, x times b over y times a. So for example, if we have 1/3 divided by 1/2, well, that's just 1/3 times flip 1/2, 2 over 1, which is now 2/3. And you might see division written in some different ways. For example, if you have 3/5 divided by 4/7, you might see that in a compound fraction, like 3/5 divided by 4/7. Just remember, you can turn this into multiplication just by flipping that bottom fraction. 3/5 times 7/4. And now that's 21 over 20. And that's multiplication and division. Not too bad. All right, next big thing we need to talk about is reducing our fractions. What does it mean to reduce fractions and why do we do it? Well, it all comes from the fact that these two facts, that anything over itself is equal to 1 and 1 times anything is equal to that thing. So what do I mean by that? So suppose we start with 2/3 and I multiply that by 4 over 4. Well, 4 over 4 is just 1, so multiplying anything by 1 is itself. So 2/3 is equal to, if I do this multiplication, 8 over 12. 2/3 and 8/12 are the same number. And I can multiply by a different one. Suppose I keep going. I multiply by 3 over 3, which is also 1. Now this is 24 over 36, which is the same number as 8 over 12, which is the same number as 2/3. And I could keep going forever. So there's an infinite number of fractions that all mean the same value. So reducing fractions is just a matter of undoing this process, going backwards in this direction. We want to work with the smallest possible reduced fraction because these are easier numbers to work with than bigger numbers here. So reducing fractions is looking for these common factors. So for example, if we have 8 over 12, we need to recognize that 4 is a common factor of both. We can write this as 4 times 2, and we can write this as 4 times 3. And once we do, we have 4 over 4, and we can cancel that out because it's just 1. And now we've reduced 8/12 to 2/3. Now to save steps, what we're really looking for is the greatest common factor, or the largest that's common to both. But it's okay if we don't find it right away. It will save us steps if we do, but even if we don't, we can just repeat our process of looking for any common factor and just keep going until we get to the bottom. So for example, 24 out of 36. Well, if we didn't know what the greatest common factor was, just look for any common factor. And an easy one to check for is 2. It's really good. It's easy enough to see whether or not both numbers are even or odd. If they're both even, then you know 2 is a factor. So this is 2 times 12. This is 2 times 18. We can cancel those 2's out, and we're left with 12 over 18. But these are also even. So I can repeat this process and take a 2 out again. 12 is 2 times 6. 18 is 2 times 9. Cancel the 2's, and now I'm left with 6 over 9. We can go one step further and see that 3 is a factor of both of these. So I can take the 3 out. 6 is 3 times 2. 9 is 3 times 3. We cancel the 3's, and we're left with 2/3. Now that's fine, but notice if we were able to recognize at the start that 12 is actually a common factor of both of these. This is 12 times 2. This is 12 times 3. Now we can cancel the 12's and get to our answer just a little bit quicker. So we're looking for the greatest common factor to do the least work. But if we don't find it, it's okay. We just keep doing the steps until we get down to the smallest possible fraction. All right, some helpful hints as we go here. My first advice is reduce early as you can. So what do I mean by that? Take, for example, this string of multiplications. I want to multiply 9 over 16 times 5 over 6 times 4 over 10. Now, if we just blindly apply the multiplication rule without thinking about it, which we can do, we get some rather big numbers here. So I have to multiply 9 times 5 times 4, which gets me 180. And then 16 times 6 times 10, which gets me 960. Now these are big numbers, and we'd have to do some steps to reduce these from here, which we can obviously do, but even to get these numbers was not all that easy. Multiplying 16 and 6 took a little bit. These are large numbers. And again, it's easier to work with fractions when they're small numbers. So rather than just blindly applying the rule right off the bat, look for ways to reduce early. And remember, we don't have to reduce just 9 and 16. These are all multiplied and divided together, which means they commute. So I can cancel anything on top with anything on bottom. For example, I know that 5 goes into 10. 10 is just 2 times 5. So if I replace that 10 with a 2 and a 5, the 5 cancels, becomes a 1. The 10 cancels, becomes a 2. You'll notice we can do the same thing with 16 and 4. 4 goes into 16 4 times. So we replace the 16 with 4, replace the 4 with 1. It's like we're dividing out that common factor. What's the common factor of 9 and 6? 3 is a common factor, so I divide both of these numbers by 3. 9 divided by 3 is 3. 6 divided by 3 is 2. So look what we've done. Before we even started the multiplication, we've reduced this to 3 over 4 times 1 over 2 times 1 over 2. And this is so much easier of a multiplication to do. 3 times 1 times 1, 4 times 2 times 2. So the rule of thumb, reduce as early as you can, and it's going to keep your numbers easier to work with, and you won't have to use your calculator nearly as much. On to the harder operations, adding and subtracting. So sometimes this is easy. It's easy when the fractions have the same denominator. So I have something like a over x plus b over x. X's are the same thing. Well, then you're just adding a and b. This is a plus b over x. Example, if we have 1/3 plus 4/3, 1 plus 4 is 5/3. All right, how does it get harder? It gets harder when the denominators are different. So let me show you the rule first, and then we'll see how to work with it. So for any numbers, x over y plus a over b, we have to do this cross multiply trick. So I'm going to take the top of the first fraction and multiply it by the bottom of the second, x times b, then do the reverse plus y times a, and then put this over, multiply the bottoms together, y times b. So what does that look like? If we had 1/3 plus 3/2, by the rule, I multiply 1 and 2, add it to multiplying 3 and 3, and put it over 3 times 2. And that's 2 plus 9 over 6, or 11 over 6. Now take a second to think about what we're really doing here. What this whole process does is forces a common denominator for these two fractions. So remember that if we multiply something by 1, it doesn't change what it is. So I can multiply either of these fractions by any of these special ones, and it doesn't change what they are. So look what happens when I multiply 1/3 by 2 over 2, using the denominator of the second one. And I'm going to multiply 3/2 by 3 over 3, using the denominator of the first one. So by our rules of multiplication, we have now 2 over 6 plus 9 over 6. Since these are now the same denominator, we can just add them together. 2 and 9 is 11 over 6. This is what we're doing to figure out a common denominator. This is the formula that does it all at once. Now, just like before, my recommendation is to look for ways to make this simpler for yourself. Rather than just blindly applying the formula, if we can find ways to reduce early, change the equation less, it'll be easier. So for example, suppose we have 3/4 plus 3/2. Now, blindly applying the formula will lead to this. Well, let's see, that's 3 times 2 plus 3 times 4 over 4 times 2, which is going to be 6 plus 12 over 8, which is going to be 18 over 8. Notice how that is not reduced, which means we'd have to do some more work to get it to be reduced. So if instead we take a second and see if there's any easier way to do this. Well, what's my ultimate goal here is to get a common denominator for both, but I don't actually need to change this first fraction at all. I can get a common denominator just by changing the second fraction and multiplying by 2 over 2. This now looks like 3 over 4 plus 3 times 2 is 6, 2 times 2 is 4. So 3/4 plus 6/4 is 9/4. This is reduced. So we've saved ourselves some work here. So remember, try to keep your fractions small. The less you have to change, the better. Sometimes there's a common denominator by just changing one fraction instead of changing both. So slow down, look for the easier way. All right, let's take a look at working with fractions containing variables and in equations. So in general, working with variables, we just apply the same rules. So if we have a common denominator with a variable, x over 2 plus 3 over 2, well, that's just going to be x plus 3 over 2. Just remember your rules for combining like terms. We could have 2x over 4, which again, we can reduce that. 2 over 4 reduces to 1 over 2. And if there's an x there, we don't need to write the 1. 1 times x is just x, so we can leave it as that. And just a notational thing, keep in mind, if you see something like 1/2 x, that's the same thing as x over 2. So just a little more compact way to write that. So working with equations, suppose we want to solve for x in a basic equation like this, x over 2 equals 7. So remember, solving for x just means isolating x, getting it by itself, undoing all the operations that are here. So remember that we have x in a fraction, x over 2. Fraction just means division. So I undo division with multiplication. And remember, we do same operations on both sides. So if I multiply both sides by 2, times 2 here, times 2 here, you'll see I get a 2 over 2, which cancels out. So we've undone the fraction, leaving x by itself and solving. X is 14. Now, sometimes you'll see a fraction equal to a fraction. We call these proportions. Something like 2x over 3 equal to 4 over 5. Now, we still just undo all of these operations. If it's division, we undo it with multiplication. But a quick step to do all this at once, we call cross multiply. I'm going to multiply these two things together and set it equal to multiplying these two things together. So 2x times 5 is 10x. Set that equal to 3 times 4 is 12. And now we've undone our fractions and we can solve this normally. So that was cross multiply. Now I'm going to divide by 10 both sides, which leaves me with x equals 12 over 10. And then we want to reduce that. 12 and 10 are both even, meaning they're divisible by 2. So 12 divided by 2 is 6. 10 divided by 2 is 5. And that's our answer. All right, let's try another slightly more complicated equation. Something like 3 times the difference of 2x and 4. All of that over 4 equals 9 over 2. So remember, our goals here are to try to reduce as early as we can, keep our numbers small, look for ways to not just blindly apply rules, but to see if we can find ways to make it simpler. So I'm going to list you my steps over here. The first thing I like to think of is getting rid of the fractions so we don't have to work with them. So again, fractions mean division. This is the left side divided by 4, the right side divided by 2. So if I, on both sides, multiply by 4, That's going to undo all of the fractions. If I multiply 4 on this side, I can cancel those out, which just leaves me with the numerator, 3 times 2x minus 4. And multiplying by 4 on this side, I have a 4 over 2, which can reduce, changing that 4 to a 2 and the 2 to a 1. So now we have, on this side, 9 times 2, 18. My next step is try to make the numbers smaller. Rather than multiplying this 3 through here, which is going to make our numbers bigger, I want to divide by 3 on both sides, which dividing by 3 here cancels out that 3, leaving me with 2x minus 4. Dividing by 3 here, well, that just has a whole number answer. 18 divided by 3 is 6. And now this is just like early algebra. We're going to add 4 to both sides. 2x equals 10. And last, we divide by 2 and get x equal to 5. So there's other ways we could have approached this, but this kept our numbers really nice and small. Let me show you another way that would have worked just as well, though. Starting with the same beginning, 3 times 2x minus 4 over 4 equals 9 over 2. Let's do the cross multiply trick. So I want this numerator times this denominator. That's 2 times 3 is 6 times 2x minus 4. And then multiply these together. 4 times 9, 36. So our numbers are a little bigger this way, but not too bad as long as you recognize what's our next step here. Well, I'm going to divide by 6 both sides, getting rid of this 6 to give me 2x minus 4. And then 36 divided by 6 is just 6. And now we're at this exact same step. Last two steps are the same. All right, last thing, let's look at some kind of weird compound fractions. So if we have a 1/6 over 3 plus a 1/3 over 6, how do we approach something like this? Well, the idea is we want to make it simpler for ourselves, try to get rid of the compound fractions, and our trick is we can multiply anything by 1, any special kind of 1 that we want. So what kind of a special 1 would make either of these fractions easier? So let's look at the first one first. You're always looking at the denominator because that's what we can undo. So what could I multiply the top by to undo this fraction? Well, 6, obviously. 6 times a 1/6 is just 1. So if I multiply it on the top, I also multiply it on the bottom. Now this is just multiplying that by 1. 6 times a 6 is 1. 6 times 3, 18. Same thing over here, except I'm choosing 3 over 3 because that's what would undo this fraction here. So this now becomes 1 over 18. Now we can add these together normally. This is 2 over 18, and that reduces to 1 over 9. All right, I hope that was helpful and you feel a little bit more comfortable with fractions now. Remember, for tutoring, feel free to email me at mathteacherjake@gmail.com. Thanks, guys. We'll see you next time.